Okay, so we're going to call this set of notes 4.1, okay? And we're working with operations with radical expressions. Radical expressions. Now, when I say operations, all right, I mean mathematical operations. So we're going to start with simplifying, and then we're going to build up to adding, subtracting, multiplying, and dividing. Okay? All right, so the first thing you need to know is, what is a radical? What is a radical expression? So we're going to look at the anatomy. Look, we're in science class now. The anatomy of a radical. Okay? All right, so here's what a radical looks like. It's like a square root, all right? But it doesn't have to be a square root. There could be any root right there. All right, and then there's something underneath the radical. All right, so when I say the anatomy, I want to talk about what everything is. All right, so the symbol that, I don't even know how to describe it. I don't know, it kind of looks like a check mark with a flat top. I don't know. That's your radical sign. All right, so that's your radical, or the radical symbol, I guess. That's your radical symbol. All right, the little n, that's going to be a number. All right, that represents what we call the index. All right, and that just indicates what root we're taking, okay? Because the radical is the same thing as taking a root, all right? So it could be a square root, a cube root, a fourth root, all right? So the index is just a little number, all right? And then the stuff underneath it, that's called the radicand, and that's the part that we're actually going to be simplifying, okay? That's the part that we're going to be simplifying. So that is our anatomy of a radical. That's the name of all the parts. All right. Okay, so we're going to be simplifying these a specific way. And you did some of this in Algebra 1. Okay, you did some of this in Algebra 1. So I'm hoping that once you see it, it comes back fairly quickly. All right. So we're going to just start with simplifying constants. Simplifying constants with factor trees. All right, y'all know what I mean by a factor tree? Anybody remember what that means? Anybody at all? No, not yet? Can't remember? Okay, that's all right. All right, so the first thing you're going to do, the first step is to break the radicand. Where is the radicand? Where's the radicand? We just labeled it top. Okay, it's the A. It's the stuff under the root. Okay, you're going to break the radicand into prime factors. All right, that's what the factor tree does. Okay, so I'm going to have a running example here. All right, so we'll start with something basic like the square root of 32. Okay, now the reason we need to be able to do this is because 32 is not a perfect square. But you're also not going to be giving me decimal answers. Okay? And so that's why we have to learn how to simplify these things. All right, so when I say break it into its prime factors, all right, that's what we're going to do when I say make a factor tree. All right? Can someone tell me any two numbers that multiply to give you 32? Come on, it's not a hard one. Two numbers that multiply to give you 32. 2 and 16. Okay. Good. Now, 2 is a prime number. Prime meaning the only factors that it has left are 1 and itself. Okay? But 16 is not a prime factor. So we have to keep breaking it down. This is how the tree forms. Okay? Well, give me two numbers that multiply to be 16. 4 and 4. Okay. Now, 16 has been broken down. So you need to get into a habit of crossing it out after you break it down. Now, are 4 and 4, are those prime numbers, or do they have more factors? There's more, okay? What, give me two numbers other than 1 and 4 that multiply to be 4. Can't be 1 and 4. 2 and 2. So I broke that 4 down, and then I'm breaking my other 4 down. If you break it down, cross it out. Okay, now everything that's left are prime numbers. So that's what I mean by break the radicand into prime factors. You still with me? Okay, now, step 2. The index, which is sometimes called the root, okay? The index or root tells you how many factors must match to simplify. Okay? Special note, if there is no index, like our example here, the index is 2. All right, can somebody tell me why the index would be 2 in a problem like this? What is, if I were to read the original, what would I say? The square root of 2. Well, since it's the square root, that's why the index is 2. Okay? All right, so what you're going to do is you're going to circle sets of 2, 3, 4, etc. based on the index. Okay, so this index is a 2, right? It's a square root. So I'm taking my prime factors and I'm circling sets of 2. So pairs. I'm circling pairs. Are you with me? All right, so I have a pair of 2s and another pair of 2s. So I'm circling pairs. That's the same thing as a set of 2, all right, because my index is 2. All right, now, each circle, or circle, let's say each circled group, brings 1 of that factor outside, all right, of the radical. Any prime factor not circled stays under the radical. Okay. So what does that mean for our example over here? Well, we circled 2 pairs of 2's. So for each circle, we're going to take 1 2 out. Okay? So I'm going to write a 2 times a 2, because I have to take out 2 2's, 1 from each pair. And then I'm going to make my radical sign again, my radical symbol, and anything that I didn't circle, any prime factor that I didn't circle, goes back under the radical. And now I just need to simplify what's left, okay? So the last step is to clean it up, if necessary. Clean it up. All right, so that means I have to actually do any multiplication in front. And if I happen to have any multiplication underneath, I would have to do that as well. All right, so according to the steps here, the square root of 32 simplifies to be 4 times the square root of 2. All right, now if you wanted to check yourself, you could type in the square root of 32 in your calculator and get a decimal. And then you could type in 4 times the square root of 2, and you better get the same decimal. Okay? All right, so let's practice a couple. All right, so for my practice, I want us to look at the 4th root of 192 and 2 times the cube root of 48. All right, and this is why I said you might want to have a calculator, because some of you may or may not know what multiplies to be 192. Okay? So remember, we're breaking it down into prime factors first. We're making a factor tree. So I just need to know 2 numbers that's not a 1 and and itself, that would give me 192. Well, 192 is even, right? So what definitely goes into it if I can't think of anything else? 2. All right, so let's just start with that. 2 times what? 96. Okay? So we can never look at the 192 again. Now we have a 2 and a 96. All right, 2 is prime, so that one's done. All right, now I need a pair that gives me 96. 6 and 16, are you in big? All right, good. 6 and 16. Cross out the 96. Are either one of those prime yet? No, so we need to keep going. What gives me 6? 2 and 3. Are those prime? Yeah, so 2 and 3 are done. Move on to the 16. 4 and 4. Thank you. Cross out the 16. Well, 4 and 4 are not prime yet. Each one of them breaks into a bunch of 2's. All right, so your factor trees could potentially get really big. But the cool thing about a factor tree is you don't always have to start with the same pair, but you will always end with all the same prime numbers. Okay? All right, so this is a what root? What's the index? 4. So we are circling sets of 4 of a kind. All right, do you see 4 of any one number? Yeah, there's 4 2's right there. Once I circle them, I can't use them again. Do I have 4 of anything else? Okay, so anything I circle, I take one of it and write it down outside of the radical. If I have things that I didn't circle, they go back under the radical. It still has to have the same index, has to be a 4. And so, but I have to write them down. Now, once you get used to this, you can multiply those together before you write it down. But you have to understand that anything that you don't circle goes back under, and it has to get multiplied back together. All right? So my final answer here has a 2 in front. It still has the 4th root. And then what's 2 times 2 times 3? 12. So that is my final answer. Questions? All right, well, number 2 is just slightly different. It has a number in front. We'll take care of that in a little bit. The factor tree only goes with the stuff under the radical. Okay? So I need 2 numbers that multiply to be 48. Any 2 numbers that multiply to be 48? 6 times 8. Are either one of them prime? No, so I have to keep going. All right, give me 2 numbers that multiply to be 6. 2 and 3. Cross out the 6. Once you break it down, you can't use it again. All right, how about 8? 2 and 4. Are we done? Nope, 4 is another 2 and 2. All right. Based on the problem, I have to circle sets of 3. Where'd you get that from? The index, okay? So I need sets of 3. Do I have 3 of the same number? Yes. And they don't have to be next to each other. I just have to I'm just looking at my prime factors. I need a set of 3 of a kind. Can I circle anything else? Okay. Now, here's what's different about this problem. There's already a 2 in front. Yes? So that's going to stay in front. And then I'm going to multiply it by anything else I bring out. What am I bringing out? A 1, 2, right? Because I have 1 circle. And then I copy down my radical. And then anything I didn't circle has to be a prime number, right? I can't go back to the bigger numbers. Goes back underneath and will get multiplied together. All right, so what's my final answer here? 4 cube root 6. Questions? Questions? Now we're going to look at simplifying variables. Simplifying variables. All right, now there's really 2 ways to think of this. All right, you could write them out and circle sets. And you'll see what I mean in a minute. So you could write them out and circle sets, just like we did with the numbers, okay? Or, all right, you could divide each power by the index, all right, and then the remainder, y'all remember how to divide and get a remainder? Goes back under. It'll make sense in a minute. Okay? So you could write them out in circle sets, or we can divide by the index, figure out the remainder, and work it that way. right, so that's like my only note on this one. We're going to go right into an example. Okay, so practice. And we'll make it pretty straightforward and basic. One letter right now. Fifth root of x to the 7th. All right, so first of all, what do I mean by write it out and circle sets? Well, I'm talking about writing out the radicand, the stuff underneath. Well, x to the 7th, if I were to break it down into its prime factors, would come from x times x times x times x times x. 1, 2, 3. All right, x times itself 7 times. Okay? Well, first of all, I need to circle sets of 5. How many sets of 5 do I have? 1. Remember, if we circle it, it comes out of the radical, right? And if we don't circle it, it goes back under the radical. Well, how many x's are going back under the radical? 2. X times x would give me x squared, and that would actually be my final answer. Okay? Now, that's all fine and good. You're welcome to do that, but what if it was like x to the 21st? Do you want to sit there and write out 21 x's and circle sets of 5? I don't. So that's why I say you can do the or divide. All right, so what do I mean by that? Well, what's 7 divided by 5? Like, how many times can 5 go into 7 evenly? Once. And then what would be the remainder? 2. So it goes into it evenly once, and then I have 2 left over. That's how I do that. Okay? So you can choose to do it either way. All right, so let's do one more like that, and then we will put it all together. All right, now I'm going to give you 2 letters. All right, let's say I want the cube root of a to the 4th, b to the 9th. Now again, you're welcome to sit there and write out a times a times a times a, and then b times b times b 9 times. Or you can ask yourself, okay, how many times does 3 go into 4? Once. So I get to take out a once. But are there going to be leftovers? Yeah. All right, how many times does 3 go into b? To the 9th. How many times does 3 go into 9? 3. So I'm going to take out a b cubed. All right. Now, you told me there was some left over, so you have to keep the radical the same, still the index of 3. All right. What were my leftovers? How many a's were left over? 1. Were there any b's left over? No. So that is my final answer. All right, so let's put it all together. Put it all together. Here we go. I'll slide it up in just a second. I want us to look at the cube root of 1080 times x to the 5th, y to the 2nd, z to the 15th. And I want you to take a second and see what you can do with that. What are you looking for sets of? Sets of how many of a kind? 3. Good. All right, someone tell me what they started with for 1080. What pair did you guys start with? 10 and 108. Any particular reason you started with 10? I mean, I know there's a reason I started with 10. Yeah, if it ends in a 0, it's divisible by 10, right? It's a great place to start. Okay, does 10 break down more? Yeah, into what? 2 and 5. Does it matter if I write 5 and 2? Same thing. All right. And what do we get for 108? 2 and 54. Sounds good? That is not the only pair that gives you 108. It is one pair. All right. So then what gives you 54? 2 and 27. That's not the only pair that gives you 54 either. That's just one of them. Sorry, that was just really sloppy. All right. How about 27? Thank you. And then 9 goes one more time. All right, so for my numbers, I'm circling sets of how many of a kind? 3 of a kind. All right, well, this is the first time that we actually have more than one set, right? Well, what do you think you do if you have more than one set? You take one of each out and you multiply them. All right? Now, if you feel like you need to actually write it like that before you do it, you can. Or you can go ahead and multiply it before you write down a 6. All right? Now, before we put the leftovers back, we need to do the letters as well. How many sets of 3 can you make out of the x's? 1. I'm going to go ahead and change this to a 6, if that's okay with you guys. All right, how many sets of 3 can you make out of the y's? None, so you don't get to take any of them out. All right, how many sets can you make out of the z's? 5. All right, now we need leftovers. Make sure your index is still a 3. What's the only number we didn't circle that was prime? 5. All right, how many x's did we have left over after we took out one set of 3? 2. How about the y's? 2. Were there any z's left over? Nope. That's my final answer. I'll slide it up for you. All right, any questions on that? Okay.